Button accepted.
Hello everyone, my name is Tomasz Skowroński and today I will talk not only about immutability. Let's begin with mutable classes. Please, don't call them mutants. They have feelings, like you, like each developer. They have feelings, they help us not only in everyday life, like at this poster, but also in everyday programming. How? You can ask, for example, to finish before the deadline, because writing mutable code is not only simple, but also fast. So you can ask, what is wrong with mutable classes? What is wrong? What could be wrong with this little green shy boy on my left? He is easy, like easy is writing mutable code, like easy is reading mutable class. But with some time, when you add more fields, more getters and setters to your mutable class, the complexity grows and grows. And this boy isn't more nice and shy. Okay, to be honest with you, of course, mutable code isn't only about getters and setters. You can add any mutating method, but it won't be simpler. It would be even more complex because first, each time you add mutating method, you have to keep the correct state, internal state, and it won't be. And if you have already some setters, it won't be simple because anybody can destroy this state. And it is difficult to say about to talk about internal state in case of mutable classes because it's more like a data structure, not real internal state. So let's talk a little more about mutability, getter-setters. Every time you see during this talk 3D slide like this, please use 3D glasses. If you don't have them, sorry, nobody say writing mutable code is user-friendly. It is just fast and simple, nothing more. How to start with mutable code? Of course, it is obvious, it is easy. Somebody can say it is the most popular implementation of encapsulation, not me. You know, getters, setters, hidden state, but as I mentioned before, when you add setters and getters to your code, there is no internal state, so there is no encapsulation, of course. Somebody can say, not me, that immutable code is the most popular implementation of CQRS, you know, comments via setters and queries via getters. But of course it isn't. Writing mutable code is easy, fast. Sometimes there are some traps. Sometimes you have to know some tricks. For example, the correct order of methods calls. And these traps aren't only related to null pointer exceptions. Because as I mentioned before, if you mutate your objects, if you allow to do it, you have to keep correct state each time you mutate the object. In a similar way, how it is done in down in aggregates from DDD. So even writing mutable code is easy. It isn't always true. But the good news is that writing mutable code allows you to make your code more clear. Yes, not clean, just clear. Especially when you hide your boilerplate, because getters, setters are some kind of boilerplate. If you hide them behind Lombok's annotations, then you have very clear code. Yes, clear. And what you can do more, if you have some other methods, mutating methods, how you can make this code more clear? Just move them away, hide into services manager. If you don't know what to choose, just put them into utils. You can think that I am joking too much from mutability, from getters, setters, but how many utils class do you have in your code base? Probably more than 0. what is the most popular class name suffix for class called from HTTP controllers in your code. Probably they are setters. They are services. So as you can see, I am not too far from the reality. Okay, but for the moment, let's forget about mutable code, writing mutable classes, and switch your mind into immutability, because this talk will be mainly about immutability. Disclaimer at the beginning. I suppose you know that using Lombok's value or making everything final in your classes isn't enough to writing immutable code. And the second disclaimer is I'm talking about immutability, but for many purposes, for purposes of this talk, for purposes of good class design, sometimes it is good enough to write just constructor-based class, even if this object created from this class aren't really fully immutable. Of course, it won't work in context of concurrency, but in other contexts, yes, it is good enough sometimes. Writing immutable code is a little more complex. There is some cheat sheet how to do it, but this talk isn't about writing immutable class, because I suppose you know how to do it. This talk will be about how to use it with Java libraries and other tools. Even if you know these rules, if you run the tools like this for static analysis, you can be surprised of the results, because they will find a lot of issues that your class annotated by immutable. So you expect it will be immutable, and you do everything from the previous slide. You will be surprised that even though there are some issues that make these classes not really immutable. But as I mentioned, for many purposes, writing constructor-based classes is good enough. Without setters, with final fields, even they aren't really immutable. How to start with immutability? You probably know Lombok. There are some other tools. Are they better or worse? It depends, of course. What they do, why they are better? Because, for example, they do one thing instead of many, like in Lombok case. Of course, you don't have to generate constructors via during annotation processing phase. You can write it manually. You can also generate constructors in your IDE. It is obvious, but thanks of these plugins, you can also generate more things. And forget about Lombok. You can generate builders, and you can generate and configure also constructor properties annotation. It is important topic, and I will back to this annotation twice or more during this talk, because today in Java world it is a standard for constructor-based classes for immutability. What if you don't want to generate complex constructors once or each time it is code is compiling? Of course, you can use Java records. I won't spend too much time on these topics because it is fresh. You heard about records a lot of times. Probably you will hear more soon. What I can suggest is this blog, where you can find a lot of information, not only about Java records. What if you can't upgrade to newer Java and you can't use, for some reason, Java records? Of course, even in Java projects, you can write your DTOs, your API classes, like requests, responses, using Groovy, Scala, Kotlin, etc. And you know now that writing mutable code is easy, like this little shy green boy. Reading mutable code is also easy. Immutability is a little more complex, but still it is, you know how to start and how to create these kind of classes. But how do we still mutate our objects? How do we still write mutable classes in Java? I have I divided the reasons into two groups. First of them is internal, and the second is external. But internal, I don't mean only about your personal things, but everything what is related to you, to your team, your company, Java ecosystem, all kind of community, or for example, learning resources. Because almost everywhere you can find information that mutability is something normal and you have to start with it. And only when you need, for example, concurrency, then you have to switch your mind into immutability. And the external reasons are more related to tools, like libraries or frameworks, and I will talk soon more about that. We as people, we are very lazy. The same I can say about developers. And even if you know that package scope is a default scope in Java, public for classes, for methods, is still the most popular modifier. Of course, nobody today write public fields. But even though we sometimes add setters, even though we add getters, and then you don't need more constructors. I mean complex constructors, not default ones. If you remember, do you remember the famous quota for the first man on the moon? It was available on the previous slide, not this one. But when I am looking into your eyes, I think that this quota should be even more important and more useful in everyday development. Why do we still mutate our classes? Maybe because of dependency injection. If you don't recognize this sentence, you are lucky. But 10 years ago, some or even 5 years ago, it was still popular to have a choice as a developer between dependency via constructor or dependency injection via fields. Why? Because Lombok wasn't too popular. Because constructor-based dependency injection was just a boilerplate. And I hope today it isn't a problem and there is no question what to choose. But even though there are some people who can say, no, constructor-based dependency injection, no, it isn't for me. It won't work with circular dependencies. But when I hear something like this, and you too probably know that the problem isn't with dependency injection, but with circular dependencies of this guy. Okay, where else you can find dependence? Where else you can find constructor-based usage? I'm talking not only about Spring Beans. There is a case related to request params. I'm not talking about request body. Request params, like in this example, you can recognize this pattern, this HTTP usage from, for example, page request, or it is just a very popular approach for RESTful filtering. And in past, to map these attributes into your Java code, you have to write code like this for when each attribute, which query param was separated into, it was a separated argument, or you have to write custom converter, like it is done with page request. Today, there are more possibilities, and if you add, you can simply separate your request, your query params as a DTO, and you can separate it from your controller. And if you add annotation constructor properties or configure your Lombok like this, using this one-liner config file, and you can achieve usage of immutable classes or just constructor-based classes and use them to map your incoming query params into DTO and then use as one argument it in controller. Very similar use case, but this time it isn't related to HTTP, but for properties. you can, of course, use Spring to inject properties from text file or config server into your Java beans, into your Spring beans. And you can ask, what is wrong here? Because probably it is the most popular approach. And I will answer that it is the same what field dependency injection is. I mean, it won't work without setters. It won't work without reflection, for example, in your test. So how can you do it better? Can you move them into constructor? Yes, you can. And it will be similar. It will be injection via constructor. It is a little better, but as you can see, still there is a lot of boilerplate, and I can't say it is the best solution. So what can you do better? You can again separate your DTO from your Spring Bean, because we are talking here about mail properties. We can move them and group into one DTO. This class is still mutable. There are setters, getters, but we can migrate into immutable class. And thanks thanks constructor properties annotation provided by Lombok here. This class will work with properties injection. And now you don't first, because this data come from text file or config server, probably you don't want to modify them. So it makes sense to make them immutable, this class immutable. And this is the reason why there are final fields, where there are no more setters. And what about getters? Do you still need them? Probably not, because now we created not only DTO, but also some kind of value objects. And instead of writing getters, we can create methods like this one to create what we need. Don't do it in next class, like some kind of service, but do it in the class what is the owner of this data. Okay, why do we still mutate our classes? This picture is unclear intentionally. I mean, I will talk about data, not business data, not domain data, just more database data. This picture is intentionally unclear because sometimes your interface look like this. Sometimes your JPA entities looks like it only because you have 20, 30, or 40 columns in your database table, and you map them directly to your JPA entities, making monsters like this. Okay, but how? What is the relation of immutability to Hibernate? Because probably you wanna mutate your entities, load, update, etc. So there are two or more use cases when it makes sense to making your entities mutable. First of them are events. I mean, probably you have a lot of events in your system, and if you, for some reason, don't use Kafka, I know everybody do it, but maybe you don't, then you can store them in a database. And then, because they are events, they represent facts, something what happened, probably you don't want to modify, you don't want to mutate them. And another use case is invoice. It is when you create invoice, and you can modify it only until it is a draft of invoice. When it becomes a real invoice, when it is released, you can't, by the law in Poland, for example, you can't modify it. You have to create another invoice, correcting ones. And if your domain is modeled using JPA entities, for example, or Hibernate, you can express this fact about immutability in your entities. First, you have to add this annotation, immutable. And the second thing is, of course, constructor. There is one thing more. You have to replace default setting from the configuration from warning to exception. Because if you mark your entities immutable, probably you don't want to allow to modify them. And if you switch this flag into exception, you will prevent. But there are two warnings. I mean, of course, still this data is available via database, what is obvious. But what is more, you can, even it is immutable, you can still, using Hibernate or Entity Manager, delete this entity. And you can still update this class using Hibernate via native update queries. But still, I think if you want to express immutability in your domain, like for invoicing, it makes sense because, for example, someday a new guy can try to add a mutating field, mutating method to this class and destroy it. Why do we still mutate classes in Java? Maybe because of performance, because of a cost of object creation. And what if I tell you that maybe this cost is overestimated? Maybe it isn't the most important thing. Maybe from, for example, garbage collector point of view, performance will be even better for immutability, thanks of immutability. What if I ask you, are you sure that performance is the most crucial architecture driver in your system? Aren't your system next enterprise web-based system where each user interaction is related to HTTP request, network latency, and HTTP response? If yes, probably you will say yes. Are you sure thinking that performance is the most crucial in your application? Maybe there are more important things. Of course, as I mentioned before, writing immutable classes is more complex, but sometimes you have to. And I'm talking not only about concurrency, but also about caching, hashing. I'm aware that sometimes strings or numbers are good enough to provide keys, but it works only because of immutability. And even these classes are more complex, it is simpler to prevent, to protect the state, or to allow state modification, and I will back to finished state machine soon. Do you know what are the most popular building blocks in functional programming? Except functions, of course, it is immutability. You know, when you have input at the start, output at the end, and your code inside, and there are some side effects, but it is just a scientific name for mutability. And functional programming works thanks functions and immutable data. And even writing immutable code is more complex and it isn't faster. You can still achieve some values from that and make your code design better. Just a few words about value objects. As you know, all classes can be divided not only in domain-driven design into entities and value objects. And the main difference is that value objects aren't identified via IDs, but by the whole content of them. And what I mentioned in context of Hibernate, for example, but in general, probably all kind of events, even they don't represent facts from the past, but they are just messages, probably all of them should be immutable. Because if something is sent, you don't want to modify. Maybe you want to replace them, but not modify. A very short exercise from value objects for you. What type is best for person age? Probably you feel that it is some kind of number. And if your system is just a CRUD, integer, maybe big decimal will be good choice. But are you still but in other cases, when you want to do something more with this person age, not only move from database to UI, not only move from one application to another, probably it won't be a good choice. Remember that about math. integer numbers in general have custom maths, and your age probably isn't something what yes, you can add that. You can maybe multiply them to ages, but does it make sense? That it makes sense to divide one age by another? I even can't imagine a discount policy that could do something like this. And remember that we aren't JSON programmers. Intentionally, I didn't say JavaScript programmers because of diversity and because they have feelings too. We aren't JSON programmers. We don't have to write only strings, numbers, and arrays. In Java, we can create simple new types, even it is only a wrapper for a one field like age. Even though it often makes sense to create a value object, especially today when you can use Lombok, when you can use Java record. It's simple and make sense often. What I will try to show you now is a short story of Java ecosystem, Java language. Because I have a theory that immutability is somewhere here at the end, and maybe it isn't a big revolution of Java, even the time is long here, but this evolution of language is important, and as you can see, everything from this list is in some way related to constructor-based classes or immutability in general. And I hope that if you wanna, that someday we will receive, for example, immutable collections interfaces. And as I mentioned, even it isn't a big revolution. I think that if you wanna be a part of this Java evolution, you have to follow this path and think more about immutability. How Java libraries, Java frameworks work with deserialization in context of immutability. Can you deserialize JSON or XML to immutable class? So when I was working on this talk, my assumption was that, yes, today everything will be possible. We have Java records, we have Lombok, so no surprise, but it isn't really true. There are some tools like these libraries that aren't ready. And even official documentation say that if you need something like this, like deserialization to immutable objects, it's better to migrate, for example, to JSON. Can you deserialize Java objects into JSON, and why not? So you can, but what you have to do is just upgrade your... Oh, sorry. You can, but you have to apply one of 3 or more solutions. The first of them is probably the worst, because you have to add JSON property annotation for each field, and then via reflection you can recreate immutable object. The second solution to deserialize to immutable objects needs only one solution, and you can recognize annotation that was mentioned a few times before. It's construction properties, and below, during this talk, it was generated via Lombok. But now you can see how to configure them, and it is trivial in case of simple classes when you have 2, 3, or more, just a few fields. But of course, in more complex cases, you have to configure this annotation and in longer way, and it is the reason why you can delegate it to Lombok, and it won't be probably bad decision. But using JSON is also with immutable classes is also possible without annotations. Thanks of Java 8, you can add configuration flag to your compiler, and then metadata with fields names will be stored into your bytecode. Field state machine were mentioned before, and my question is, can you mutate immutable objects? And the answer is yes, if you write broken code and this class isn't immutable. Or the answer sounds yes, if you wanna maybe not mutate this kind of class, but just modify or change the state. And it is very simple in case of when you wanna modify just one field, one or two. You just need to recreate whole object with and replace the changed part. You can do it, of course, with Lombok using annotation wither or using annotation builder to builder true, and then you can recreate builder from object and build similar object again, but with different value, with different field. You can think that I am a little fanboy of Lombok, but it isn't true. And what is more, I don't like more exotic annotations from Lombok. And it probably won't be surprised if I tell you that some of Lombok's annotations should be forbidden, like setters or data. But even though I think that Lombok is today one of the most popular answer for constructor-based classes and boilerplate, there is time for more complex example of changing a state of immutable class. I'm aware that it looks like a rocket science, but it is just an example, don't worry. Here you can see one rocket, and this picture shows you a life cycle of this rocket. As you can see, in each stage, it drops some element, or for example, at the end, it opens wings. And how to model this process using mutable code? Of course, it is very simple. You have for each state transition, you have a method. You have to check you are in the correct state, and then you can migrate to the next. You can transfer this object to the next state, removing unneeded more fields. How you can do the same in immutable world? You have to write a class for each stage. All of them implement the same interface, and you have only one method. Just move to the next stage, and you return the correct implementation of the next stage. So all state transfer is type safe, and you can't do it wrong. If it wasn't clear, very similar solution is used here. There is a response entity builder from the Spring, but it is a real builder, like a design pattern is used here, not builder from the Lombok, not only from the fields setting. As you can see at the comments, there are stages. I mean, first you can imagine that there is a builder method at the beginning and build method at the end. And these comments explain what stage is now available. And thanks of this approach, thanks of this builder, you can, for example, first you have to provide a status, like OK in this case. Then you have to add 0 or more, one or many headers, and then you can add only once or none body. And in this way, you can't create, for example, response entity with many statuses. You can create only valid object. What about testing? Can you, for example, use final classes with Mockito? So the answer is no, until you upgrade to Mockito 2 or newer and configure it using this one-liner. But before you do it, you have to answer these questions, because if you need mock, stop, or spy some value objects or final constructor-based class, probably something went wrong. Because if you have a DTO, immutable DTO, if you have value objects, maybe there is no sense to stop it. Maybe you can just create the real object using constructor. Constructor is intentional named. It isn't a random thing. It is for for object construction. There is also, if you have, on the other hand, if you have some junior developers or Bootstrap spec ops in your team, probably you can think about don't mock annotation, the new thing, and if you add it to the class, it won't be possible to mock or stop this class. We are almost done. How do you think, what is the main message from me to you? What is the main message of this talk? Do you think I accept from you to stop writing mutable code, to make everything immutable? Of course not, especially if you write a game or if you create embedded software. But also JPA entities aren't best choice to write immutable classes. Yes, there are some examples like invoicing, but the rest of them, of course, should be mutable. So what is the main message of this talk? Maybe this one. I think no. I hope it is obvious. You don't write setters, even if you can. The main message of this talk is, first, please reduce mutation in your code base. And the second thing, please think about immutability not only in context of concurrency, because it is a very powerful tool and you can apply it to write better code and to provide better design of your classes. Thank you and see you on the trail. One more thing. It will be very important for me if you will visit this website and just, even if you don't want to type anything, any comment, you can just click to provide me some feedback, to provide some score, and it will be very helpful to provide better and better talks next time. Thank you.